In this video, I'm going to demonstrate the process of taking partial ownership of an object that comes from automation. So for this example, I'm going to use the ProbSevere objects that are assigned to the severe hazard type, but just for simplicity's sake, and just to let you know that the process of using this for lightning is approximately the same with some subtle differences, but in terms of the widgetry, it's approximately the same. So when we look at the map here, we have some objects that are given to us from ProbSevere. These are identified from the composite reflectivity field from MRMS, and they update approximately every 2 minutes. And when we look at the values here, we see that there's an ID associated with this. We truncate that to the last 3 digits for simplicity. There's a P4 on each object. The P comes from the type of prediction that is assigned to it. In this case, it's the persistence option. I'll explain more on what all of that means in just a few minutes. The 4 stands for the level of automation. Levels of automation, if we go to the training, 4 is total automation, and that ranges to level 1, which is complete manual control. And in this video, I'm going to demonstrate going from a level 4 to a level 3 and talk about how you get to a level 2. Below that then is the percentage that comes from ProbSevere. To start, we click on the object, and before we get to the modification part, which would be the next step, we can look at some of the diagnostic variables, and more importantly the trend in those variables as a function of time. So here's the direction. Here, for example, is the mesh trend, obviously pegged above 1 inch, but bouncing in and around 2 inches for the last 2 hours. We also tag LSRs to the object. Those are both temporally and geospatially dependent, so it's a object-dependent breadcrumb trail of reports. Another thing we can look at, max low-level azimuthal shear. These are radar variables here. That's been trending up, so this can perhaps help in terms of your improving your conceptual model of the storm and what kind of environment it's in, how it's trending, and things like that. So again, we got to click modify, and when we do that, we get all of the first guess information populated on the widgets for us that we have available. So to start with, the advisory product that's selected, that comes from the automation. So the automation is only capable of producing advisory products. The power to make a warning decision lies with the human forecasters. So the automation cannot ever produce a warning. We have decided that can only be done by the human forecaster. In this case, we saw the mesh trend, so we are probably thinking about doing a warning with this supercell. Then for severity, we have a couple of tags, options for severity, the hail and the wind. We saw the mesh trend, so I'll put up something near golf ball size. I'll just put winds at 60. Source will be observed. So from there, we get into the motion and duration values. The motion values come from the automated tracking of the object as a function of time. So 206.36 knots. The duration comes from a machine learning algorithm that we're running here at NSSL. So if we go to the training and go make sure we're on the total severe, first we can read all about ProbSevere. There's some helpful links and information here, but also sort of a quick summary of what the goals, methodology, predictors, etc. Below that, we have some object predictability and buffer statistics. I'll explain those in just a few minutes. Below that, we have the object predictability, the object probability predictions. I'll explain that in just a second. And here is the duration section, so we can learn about how those come about if we look at that section there. But just like with the manual object creation and modification, if we just go back a few frames on the map, this will take the object that we had and extrapolate it back in time based on the vector. And so we see probably a geospatial mismatch here, where the radar reflectivity is a little further north of where the extrapolation puts the object, as well as where ProbSevere had identified the object at that earlier time. So to make that correction, we can just drag this object a little bit further to the north and perhaps northwest, and you can see that that has then shortened the distance between these two centroids, and as a result then the plume is a little shorter, meaning that our speed has come down and it's a little bit more of an easterly trajectory as well. So again, return to the current frame and you get your widgets back on the left. We can override these values, but we already did that, so they turn bold here. Before they were just a regular font, now they're bold, meaning we have control. And if we change this value here to say 60 minutes, you see that that turns bold and we get a longer plume as a result of that. The next widget here is the object shape and position. This is only something that you get when you're working with automated objects. Manual objects will not have this option. And the important distinction between the levels of automation, if we scroll back to the top here on the training, the level 2 and level 3, the thing that distinguishes those two levels is whether or not you have control of the object's shape and position. And that is controlled with this checkbox. So right now it's checked, meaning that we would be going to a level 3 of automation, given that we've overridden at least one variable from the automation, which we did by changing a lot of these things up here. To go to a level 2, we would just uncheck this box. And when we do that, what you'll notice right away is that now we have this bounding box that gets drawn around the object. And this allows us to then make some modifications to the object shape. If we were to issue this, it will take whatever we do in terms of adjustments, with the option of having some of these variables still remaining automated. If we check this box back, what that will do then is flip you back to the level 3. You lose the bounding box, and now our only option is to drag the object on the map. When we drag the object on the map, say for example we think it's a little bit too far north in its object identification, we drag it a little south, you can see that the object offsetting X and Y positions fill out here on the left. So we drag it a little bit further to the south, so we get a minus 2.3 kilometer value there. You can also type and change those yourself if you want. And then another option we can do is apply a little bit of a buffer to the object. So why would we want to do that? If we go back to the training, we've done some research with these objects, and we did a 3-month evaluation. This was work done by David Harrison, a graduate student working with myself and a few others at the lab. And if we look at how, basically the performance of the ProbSevere plumes, taking the plumes going out completely automated and compare those to warnings for the same time period and conditioned on LSRs, what we see as a function of lead time is that the percent of LSRs that get warned is approximately the same. So the dashed line are the warnings, the solid lines are the plumes. You're seeing a little bit better performance in the shorter lead times with warnings, but perhaps better performance at longer lead times with the plumes. So this is encouraging to us because what it demonstrates is that if a forecaster can basically pick the same objects that they pick now, that they can get approximately the same performance that they get now. And so then one question that arises from that is, well, if you're, when you're missing those reports, how far do you miss by? And so this distribution shows that. So this is only the LSRs that miss. And what we see here is another encouraging aspect, that when we miss, most of the distribution lies on the left side here, so that we're not missing by very far. So then what you can think about then is if we apply a systematic adjustment, say with the object position like I just showed, or if we do something that's a little bit more easier to do from a coding standpoint, which is to apply a buffer to the object, then how does that affect essentially our PODs? So this is without any buffer, just showing you what it looks like. Diagnostically, we're between 0.7 and 0.8, going out almost 20 minutes, decaying from there. If we apply just a 2 kilometer buffer, that jumps to 0.8 to almost 0.9, again out almost 20 minutes, decay after that. And a 5 kilometer buffer gets us up near 0.9. So what this tells us then is that for some objects, a few select objects, if we apply a buffer to that we can increase the POD as a function of time with those objects, while at the same time keeping the same FAR, and essentially cross a skill line on our performance diagram. So this could be, kind of a performance improvement, if you will. And so in this case, I'm going to, and I applied the position offset, but I'll apply, I'll just put like a 4 kilometer buffer just to show you. And that, simply does a buffer around the object. It makes it a little bit bigger. Just for, just to demonstrate, for example, you can put a negative buffer and actually will make the object smaller. Okay, so that's where we've got the object now. I'm going to go back to the training and go to our recommended practices section and scroll down, because here now we have the prediction type, where we have two options. We have persistence and explicit. So what is the difference between these two options? Well, this little animation shows you visually what the forecast plumes and the evolution of the object would look like with those two options, with the top plume being the explicit option, the bottom being the persistence. So with the persistence, what happens is that the forecast probabilities will follow the forecast confidence trend that you put on the tool. So it will basically, after you issue, let's say 20 minutes from now you had 96% probability, what shows up here will be 96% at 20 minutes. That is different from the persistence option, which basically just takes this trend and then will slide it downstream. So that's kind of what you see here. So actually the end of the plume will basically keep going, and it'll just take the whole trend and just kind of slide it downstream. Another key difference is that the object here actually will expand with the explicit option according to the motion uncertainty assigned to it. Here the object will remain the same size and will keep that diagnostic value that you had assigned to it. So then the question is, when would you want to use these two options? And so this little graph here tries to demonstrate that within an idealized framework. And so the explicit options end up being most applicable in situations where you have forecast of some kind of change in intensity, whether that is an intensification or a decay. And so what that can do then, again, is you're basically, for example, if you have a curve that goes, if we change this to explicit, for example, and we go down here. We take these values down a little bit, and we take these values down a little bit. We click the bell option. This is an explicit forecast that the intensity is going to increase as a function of time. At least the confidence in its intensity is going to increase as a function of time. And so that would be a situation where you have this explicit option. Another example is, we can get to this a little faster. If we do this option, this might be more of a decay sequence, so that might be something to include there. Whereas for the persistence, basically what's shown here on this graph is that anytime that the hazard has reached severity, so you have a tornado, you have 1-inch hail, you have 60-mile-per-hour winds, that you'd want to use the persistence option, and that again kind of shows you what that would look like up here. So that's really helpful if you push the observed button and use the persistence value. Then basically that kind of sets you up really well. The other things, the recommendations here is that for the explicit option, if you're using automation and you're forecasting intensification, you probably want to use level 3, because that will basically take the most current object from automation and keep that plume going downstream, which will help with the lead time. Whereas if it's decay, you probably want to switch to complete manual control level 1 or 2, and that will keep it much like you see here, where the forward edge is basically constant. So that's a very in-depth thing. It's a very advanced tool, but for simplicity, we default that to persistence. That ends up being kind of a good default, really, to use in the absence of any other information. Like with the tornado option, we have some options here to default our trend from guidance using the ProbSevere value. We can use the prob hail, prob wind, prob tor, and it will just fill out the diagnostic value and linear decay. The ProbSevere actually will pull in the prediction that comes from our training. If we go back to total severe, and so down right here in this section, it talks about there is this machine learning algorithm that's used to create those predictions and fills out the trend automatically for you. So I'm going to use the observed here. When you do that, it will automatically change this tag to observed, and then I'll just type large hail and damaging winds expected with this storm. And then once you've got everything changed and modified, click issue and hit OK. And again, that's going to send the information to the server and let you know that in this case it's a level 3 object, so we went from 4 to 3 on the label. We stayed in persistence, and there's our labels. So this gives you kind of a very in-depth overview of the process of taking control of an automated object and making adjustments to it. That's all for now.